What's up guys, welcome back to another video of Frontend source code. In today's video, we're going to look at this library called TunnelRat. What this library do is it transfer React elements into somewhere else. It's kind of like React Portal, but just in a moment, we're going to see that what is different from React Portal and the TunnelRat. So first, let's look at the README for this repo. You can see here it has a short description for this library. It digs tunnel for React element to go in and appear somewhere else. So here's the most important part. It works across separate renders. You can use it to easily render HTML DOM elements from within your React 3 Fiber application. So you can put HTML element inside of your canvas. But this library is going to transport the HTML elements into the DOM tree for browser to actually rendering them. So here are some examples. You first import the tunnel from TunnelRat. Then you get this t value from invoking the tunnel function. This return value has two properties, an in and an out. You put the in component to send one or more elements into the out element. So this is the basic example. And let's look at the actual usage. Now let's look at a more complex example. Here we created this UI from invoking the tunnel function. Then we put the UI.out inside of a div element. Here we use UI.in inside of canvas element, which normally you couldn't put any DOM element inside of it. It should be only rendering 3D objects like box or mesh. But inside of this UI.in, we can actually put HTML DOM element because it will be transferred into the UI.out. So we just put it here, but we're actually rendering inside of a HTML DOM tree. So we are actually just declaring them inside of the canvas, but for the rendering, it actually happens inside of the DOM tree. Of course, you can do it the other way around in this example below. As we can see, we put mesh and the sphere geometry inside of DOM element, which normally is impossible. But in here, we actually use 3.in to transport them inside of a canvas. So it's just declaring them inside of a div element, but the rendering is actually happened inside of the canvas. Now, here is something you have to keep in mind when using this library. If you're rendering multiple in and they are all the same type of node, you probably should add a key for them. As we can see in the later source code, the UI.in is actually rendering the children as a array list. So just like in React array list, you always put a key for better performance. Now, let's look at the real source code here. First, we can see this project has a fairly simple structure. It has a source folder, a test folder, and inside the source folder, we only have two files, an index.tsx and a utils.ts. First, let's check out the utils. So inside of here, we export out a hook, and this hook is basically checking for whether we are inside of server-side rendering or client-side rendering. If we are at server-side rendering, we export out use layout effect. If we are inside of client-side rendering, we return a use effect. This is for some server-side rendering bug. If you are interested, here's the GitHub issue for this. You can go check it out for yourself. And then we have a use mutable callback. So what this hook do is actually the same as a new hook called use effect event from React 19. If you are interested in how this hook works and what's the use case for this hook, please check out the React doc for use effect event. It's pretty much doing the same thing. Now, let's go over to the actual source code inside of index.tsx. First, inside of index.tsx, we defined a type alias as props. it only has one property, which is a React node children. Then we declare a type state. It has current, which is an array of React node. I have a version, a number, and a set, which is the set state from the zoostan create stored. For the actual tunnel function, we first use create from zoostan to create a use store. Inside of this store, we have the three state that we declared before: the current, the version, and the set function. Then we just returned out a object. This object contains a in and out. So inside of the in, we first extract the set function and the version number. Then we declare a use effect with an empty dependency. So this effect is going to run every time a new component is mounted. Inside of here, we run the set function to increment the version number by 1. This is going to trigger the next use effect and causing the whole list of current component to re-render. So let's look at the next use effect hook. Inside of here, we have two dependency. First is children, then is version. So whenever the version change, we are going to rerun this effect. And inside of this effect, we do two things. First, we append the current children to the end of the list. Then we return out a cleanup function to filtering out the current children. So this effect is to make sure that every time we re-render, we are actually keeping the order of the list. And every time we insert a new children inside of the in, we are going to re-render the whole list. That's because this is the rendering logic of React ArrayList. So we want to match the logic of rendering list inside of a React. That's why we're doing this. Then we have the out component. Inside of this out, we just extract the current list and return it out. So this is how we're rendering the actual content inside of in to the proper context. All right, guys, that's it for today's video. If you find this video helpful, please leave a like or considering subscribe to this channel. It means a lot to me. And see you guys in the next video.